In this lecture, we will be looking up about inverse trigonometric functions, how the pain that they normally give can be reduced. Further, we will also be looking up the differentiation of such sort of functions, and then we will see how that can be related with application of derivatives, another topic. Now, all of this is going to be done from a scratch, so you need not worry. We're going to start from the basics and then we will elevate ourselves to the highest concept or the highest complexity which is possible. So make sure that you're here till the end of this lecture so that you can absorb all of this knowledge and also apply it to sums of your exercise. Moreover, one caution: you should have already learned the formulae of compound and multiple angles, because when we talk about inverse trigonometric functions, again and again they get applied. So obviously in this sum there'll be just a few, but obviously when you deal with such sort of sums you should be knowing all the different formulae which are there. Okay, so now let's start off with inverse trigonometric functions. As you know that whenever we talk about a function which is an inverse trigonometric function, we actually have to begin with a trigonometric function. For that matter, if say we talk about y to be equal to sine x, we know that this is a trigonometric function, right? Now this trigonometric function gives us the value of sine of a specific angle x, right? Now sine, whenever it is found out in a right angle triangle, it is actually the ratio of the perpendicular to the hypotenuse. But if we are interested in finding out x, which is the angle, then we call in the inverse trigonometric function, and then what we do is we then talk about x to be equal to sine inverse of y. Right now, children, as you have already seen that when we talk about this x actually is the angle, right? And here the value of sine of that angle is what y is. So if we find out sine inverse of this y, then again what we are to get is we are to get the angle. So the answer of an inverse trigonometric function is actually an angle that we are trying to find out, right? Now children, after this we talk about differentiation, and as you know that when we talk about differentiation we actually talk about the rate of change of a physical quantity with respect to some other physical quantity with respect to which it is being measured. For that matter, when we talk about that in mathematics, we have the independent variable with respect to which the change in the value of the dependent variable is studied. Now let us look up what this definition is. For that matter, if say we talk about y, then y can be say some function in x, f of x, right? And now if we are wanting to find out dy upon dx, then that actually is d upon dx of the function y, and this, children, can further be written by the first principle as limit h tends to 0 f of x plus h, where h is an infinitesimally small number from which f of x is subtracted, and then in the denominator we have h. Now children, let's try and break up each of these small quantities that we have here. So if you talk about f of x plus h, as you've seen that y is equal to f of x, so obviously f of x plus h also must be a value just like y. As such, we can say that this is some y at a latter value of x, or in other words at a point which is slightly ahead of whatever the value of x is. Now if we talk about f of x, then that is the value of the function at another point. And if you talk about h obviously can be written if you talk about x plus h from which x is subtracted. And as you know that x plus h is actually the later value of x, and if you talk about x is actually the earlier value of x, and thus here you can say that you're talking about a change in the value of the independent variable x in the denominator. And as here you're finding out the difference of the dependent variables, right? Then you can thus say that you're actually trying to target what? You're trying to target the change in the value of the dependent variable, or in other words it's actually y2 minus y1, which will give you delta y, right? And thus, whenever we're trying to find out the derivative of a function, then we're actually trying to find out the change in the value of the function f of x, which is actually represented also by y, with respect to the change in the value of the independent variable x, right? So this is what has to be done when we talk about differentiation of inverse trigonometric functions, right? Then, as you know that whenever we talk about differentiation, we can very easily relate it with the different applications that we have with differentiation. That is, we can talk about tangents and normals, then we can talk about maxima, minima, we can talk about rate as a measure, right? Then we can talk about increasing, decreasing functions, and so on. So a question can actually relate an inverse trigonometric function to be differentiated, and further that differentiation can be linked with the application of derivatives. As such, you get a complicated question, but if you break up each of these into small constituents and solve each of these simply, then you will actually have got a complicated question made into simple parts, which is very easily to be dealt with. So let's look up all of this, right? But before we start off, I'd like to quickly give you people a revision. So here, children, we are talking about inverse trigonometric functions. Like I told you, if you have a function which is y is equal to sine x, then this actually is a trigonometric function. Here you try to find out sine of the angle x, and in a right angle triangle, you have sine x to be the ratio of the perpendicular to the hypotenuse. And now x is what? X is actually the angle, which is in radians. And now if you want to find out that angle, then that will be equal to sine inverse of y, which is actually the value of sine x, right? So this is an inverse trigonometric function in shorts. Obviously, there are a lot of lectures on inverse trigonometric functions, whose link I will provide to you in the description, that you can look up and strengthen yourselves. Further, when we require to differentiate, what do we actually require to do is we require to find out change in the value of the dependent variable with respect to the change in the value of the independent variable. In practical life, you can talk about the velocity, which is the change in the velocity which is studied with respect to the change in time, right? So let's say we have a function y which is f of x. Now to differentiate this, it is written like dy upon dx, which can also be written as d upon dx of y. Now further, we can write this by ab initio or by the first principle, just like this, that is f of x plus h, if from that f of x is subtracted, right? And if it is divided by h, when h is an infinitesimally small number, that is, it is tending to 0, then we get the derivative of the function f of x with respect to the independent variable. Now here, children, f of x plus h is a value which is a latter value of the dependent variable, right, at a point which is a latter value for the independent variable like x plus h. So we can take x to be, say, some constant like, say, 4. So 4 plus h will be a point which will be on the right hand side of 4, right? And when from that you subtract f of x, just like f of 4, then this is actually the difference of y2 and y1, or in other words, it can be said to be delta y. And similarly, children, in the denominator, as you see h, it can be written as x plus h, from which x has been subtracted. Now x plus h is a latter value of x, the independent variable, and x is the earlier value, right? So here, as such, it will become equal to x2 minus x1, or in other words, we can say that that is delta x, or the change in the value of x, right? So to repeat, whenever you talk about differentiation, it's actually the ratio of the change in the value of the dependent variable y with respect to the change in the value of the independent variable, when the change in the value of the independent variable is infinitesimally small, right? We will not be using the first principle or the ab initio. We will directly be using the formula, but obviously you should have an idea about what differentiation is. Now, children, we will move to a sum which will actually give you a lot of idea, because this is going to tell you about an inverse trigonometric function, and then further there is also differentiation which is to be done, right, so that we can get this sum to be done. So children, I'll give you people a little time for trial, and after which I'll be discussing the sum with you. So using all the knowledge that you already have and the knowledge that I have provided you people, I want you people to try out the sum. Okay, one word of caution: make sure that you're seated at a place which is secluded so that there is no disturbance, on a table and chair, sitting straight, and that is the best way that you can focus and concentrate and try and get to the final result. Okay, coming back to discussing the sum, now we have y, which as you can see is equal to what? It's equal to sine square cot inverse of root of 1 plus x upon 1 minus x. So first what we do is we first copy this function, which is y is equal to sine square, and then we have cot inverse, and further we have cot inverse of what? 1 plus x, which is divided by 1 minus x, right? So children, now this is a function. Let's see further what has to be done. Prove that the above function is strictly decreasing function. Now, in order to find out whether a function is strictly increasing or decreasing, you actually require to find out the derivative, and that is the reason why this function requires to be differentiated, and then with the help of that we'll be able to understand whether this is strictly increasing or strictly decreasing, or probably just increasing or just decreasing function. So for that matter, children, let's talk about this function and let's try and simplify this first. You can do one thing, that is, if you take the value of x to be, say, some cos theta, then things can become pretty simple. So let's take x to be equal to, say, some cos theta, and thus children, you can now say that if you talk about theta, then theta will actually become equal to cos inverse of x, right? Now we are going to substitute this value as such. Y will now become equal to sine square, and then we have cot inverse of root of 1 plus cos theta, as we've taken the value of x to be cos theta, right? And then further in the denominator you will have 1 minus cos theta, right? Now children, I'll quickly remind you people about two formulae that we are going to use here. One that is of cos 2 theta, right? That is, if you talk about cos 2 theta, children, remember, then that is equal to 2 cos square theta minus 1. Or in other words, we can say that 1 plus cos 2 theta will become equal to 2 cos square theta, right? And thus, if you talk about 1 plus cos theta in this way, right, what is that going to become equal to? That is going to become equal to 2 times of cos square and half of this angle, as earlier you had 2 theta, right? Then you got to theta. Thus, if you have theta earlier, now you should get to theta upon 2, right? So 1 plus cos theta is going to give you 2 cos square theta by 2. Similarly, children, we have another formula, and that is this, that if, say, we talk about cos 2 theta, then cos 2 theta is also given as 1 minus 2 sine square theta, right? This is what I was telling you people, that there are many formulae of compound multiple angles which are going to be applied. So make sure that you learn all of that, and then you start doing inverse trigonometric functions, and then you will find that you will fare well doing the sums and you will get to the solution. Okay, next children, what we can do is, if we take this cos 2 theta to the other side, we will get 1 minus cos 2 theta, right? And now at this time, this is going to become equal to 2 sine square theta, right? So for the children, if we have something like 1 minus cos 2 theta, we get 2 sine square theta. What if now, if we talk about what we already have, that is 1 minus cos theta. So what's going to happen is, again, the angle will be divided by 2. That is, you will have 2 sine square and now theta upon 2. So children, these two values now we are going to substitute as such. Further, this is going to become equal to sine square. Then we have cot inverse, and then children, within root, now in place of 1 plus cos theta, we can talk about 2 cos square theta upon 2. right? And in the denominator, children, what we can do is we can now talk about 2 sine square theta upon 2, right? So here we get to see that we have 2 which is common in the numerator and the denominator, and also in multiplication. As such, it will get cancelled, right? And since here, children, we have a square root also, and they are squares, so the square and the square root are going to cancel each other. So the next step, we are now going to get sine square, and we have cot inverse of cos theta upon sine theta becomes equal to cot theta. As such, we will have cot of theta upon 2, as the square and the square root get cancelled, right? Now after that, we also get to see that cot inverse and cot will get cancelled. As such, now we will just be left out with theta upon 2. So finally this function fizzles to sine square theta upon 2, right? Now remember, children, with what did we start off? We started off with x to be equal to cos theta, right? So if, say, we can somehow bring it in the form of cos theta, then we can write it in the form of x directly, right? So since you know that this is actually the function y, so as such, we can say now that y is equal to this. And now what you can do is you can multiply both the sides by 2, and then what will happen is you will find that there will be 2 sine square theta by 2. There's another thing that you can do is you can keep y to be intact, and then you divide by 2 and you multiply by 2. As such, you don't have to change y, and thus you will get 2 sine square theta upon 2. Next now, children, as we know that cos theta can be got by 1 minus 2 sine square theta by 2. As such, you have to add 1 and you also have to subtract 1. So as such, here we will now be adding 1 and subtracting 1. Is there something more that you require to do? Well, with 2 sine square theta by 2, you also require a minus sign. As such, 1 minus sign you're going to keep outside, and the other minus sign you will take inside, so that the product of both of these becomes positive, and that is what was there earlier. Now, children, here further we have minus half, right? And within the bracket we have minus 2 sine square theta by 2. So as such, if we add 1 and subtract 1, so we'll have 1 minus 2 sine square theta by 2, right, which is actually cos x, right? And then further, as you added 1, you also require to subtract 1, right? And thus this becomes equal to minus half times of, in place of 1 minus 2 sine square theta by 2. I'll show you how. If you talk about 1 minus cos theta, that's equal to 2 sine square theta by 2. And if you take this 2 sine square theta by 2 to the left hand side, won't you get this to be cos theta? Yes, you will, right? So as such, this becomes equal to cos theta, that is just this value, 1 minus 2 sine square theta by 2, right? In its place, we've now written cos theta, and further from that, we're going to subtract 1, right? Now, children, next what we do is, as all of this is equal to y, we still write y now, and we are quickly reminded that if you talk about cos theta, we had its value to be x, and thus we can now replace that. As such, here y can now be written in the form of x. As such, we have minus half times of x minus 1, right? So this becomes the relation between x and y, and it comes out to be a linear relation between x and y, right? Now let's come to the question and see what was being asked. In the question, you have to prove that the above function is a strictly decreasing function. Okay, now for that, as we now have the function, right, to be able to find out whether it's strictly decreasing or not, what we do is we try and find out the slope of that equation. And I'm sure you people remember this, that in order to find out the slope, you require to differentiate this equation, right? So what you do is you find out the derivative of this. So as such, now we can say differentiating what will you get is you will get dy upon dx which is going to come to be minus 1 upon 2 being a constant will stay outside, times of the derivative of x, right, is going to become equal to 1, and the derivative of minus 1 is going to become equal to 0, and thus this will come out to be minus 1 upon 2, which is multiplied with 1, and thus it will come out to be minus 1 upon 2. Now if you talk about this actually has given you a negative value. That means whatever be the value of x, that means whatever point you talk about in the graph, you will always get the slope coming to be negative, right? Because I'm sure you people remember this, that if say we now talk about the slope, right, of say a graph, which is also known as the gradient, right? So we can say that the gradient or the slope, right, of a graph is given by m, and which obviously is given by tan theta, but it is also given by dy upon dx at some value of x1 comma y1. And since here you find that this is irrespective of any point, it's come to minus half, that means whatever value of x and y you keep, the derivative is always going to come to be negative, and thus this shows that the function is strictly decreasing, right? And thus you will say here that therefore the function is strictly decreasing, right? So if the slope all through is minus 1 upon 2, that shows that the line is going to represent such a line which is actually going towards the x-axis, but its slope is such that it is going from a higher value to a lower value. Now let's try and trace it out. So if say now we talk about the x-axis and the y-axis to be say something like this, that is we have it to be this say is the y-axis, and then further we will now be talking about this also as the x-axis, because we're going to change its direction. So here let's say that we have here the x-axis, right, and what else we'll do is we are now going to change it in the vertically upward direction like this. And then further we find that if we talk about this line, then this line can obviously be extended on either side, right? This represents the x-axis and the y-axis, right? And if you talk about this straight line is going to come to be such that tan of the angle will come to be obtuse, right? And as such, if you try tracing out this line, then this line will come out to be something like this, because this angle is going to be obtuse, and as this angle is going to be obtuse, it is going to fall in the second quadrant, right? And as it is an angle in the second quadrant, tan is going to be negative there, and this shows the slope is going to be negative, and thus we have made a correct figure, which is obviously approximate graphing of the line. And this also shows you that if you talk about the slope of this line, right, you will always find that the change in the value of the y coordinate with respect to the change in the value of the x coordinate will come out to be negative, right? As such, you can say that this is a strictly decreasing function. Now children, all of this I will just quickly discuss so that if there is any doubt, all of that gets perfectly cleared. So I'm sure you people must have seen that how a complicated inverse trigonometric function was converted to a simple function which actually became an algebraic function, right? And after that we also talked about the differentiation of it. Now that it had become very simple, so the differentiation also became very simple, and then further we were able to analyze with what we got as an equation that the slope is actually negative for for any value of x and y coordinate on the line. As such, the line is always having a slope which is decreasing, and as such it represents a function which is always decreasing, and as such we can say that that is strictly decreasing. Okay, now to begin, we had a function y is equal to sine square cot inverse of root of 1 plus x upon 1 minus x. Now we take this function and further we try and simplify this by taking the value of x to be cos theta, and thus theta will become equal to cos inverse x. Now this is placed in the place of x. As such, we have it something like this. Now we are quickly reminded about two formulae of cos 2 theta, that is, it's equal to 2 cos square theta minus 1, or it's equal to 1 minus 2 sine square theta. Now when we have it of the first case, then this one can be taken over to the other side, so we have 1 plus cos 2 theta, which becomes equal to 2 cos square theta. Thus, if you have something like 1 plus cos 2 theta, that is, cos is linear but the angle is double, we will have it as quadratic and the angle will be mono. That means that 2 is going to be removed. So here too, if we have 1 plus cos theta, that's going to become 2 cos square, that is quadratic, and the angle will be half, that is theta by 2, as earlier it was theta here. Now if we have cos 2 theta, that is also equal to 1 minus 2 sine square theta. So if you take this cos 2 theta to the other side and this minus 2 sine square theta to the left hand side, we will get 2 sine square theta to be becoming 1 minus cos 2 theta. Now further here, if in place of cos 2 theta we just have cos theta, what will happen is we will find that with sine now we will have to write a square, and whatever was the angle we'll write its half. That is, earlier it was 2 theta, now it became theta. So if it's theta, it'll become theta by 2, right? So this is what we now replace in place of 1 plus cos theta and 1 minus cos theta. That is 2 cos square theta by 2 and 2 sine square theta by 2. 2 to get cancelled in the numerator and in the denominator. Thus you have cot square theta by 2, whose root is going to become equal to cot theta by 2, right? Now here children, cot inverse and cot will get cancelled. As such, you will get sine square theta by 2. Now if you talk about sine square theta upon 2, from that we can get to cos theta, because we know that if we talk about cos theta can be written to be equal to x, and then if you would have brought that, then you would have first simplified the function a lot, and then obviously you will have it in terms of x and y, which are the independent and the dependent variable. So here what you do is we now talk about this sine square theta, which is first multiplied by 2, and as you're multiplying you also have to divide by 2 so that both of these cancel each other and you get the old function back. Next, if you multiply this with minus sign inside, so you'll also have to do it outside, so that minus and minus becomes equal to plus. Why do we do this? That is because we know that 1 minus 2 sine square theta is going to become equal to cos 2 theta. So as to bring it to that cos form, we are doing this. So we have minus 2 sine square theta by 2 now. Now we just have to add 1 and subtract 1. Adding 1, we get 1 minus 2 sine square theta upon 2, which actually just becomes cos of 2 times of theta upon 2, that is cos theta, right? And further we have minus 1. Now in place of cos theta, as you know, we can substitute x, so we write x here minus 1, and that is further multiplied with minus 1 upon 2. Now children, when we differentiate, only then we'll be able to find out the slope of the graph, right? So like I told you, slope of the graph can be found out by this formula, which is what? Which is that if you talk about the gradient or the slope, which is normally represented by m, then for a graph at different points it is different, and that is why you first find out the derivative of the function with respect to the independent variable, then substitute the coordinates of that point at which you want the slope, right? And at a point where it is x1 comma y1, then it gives you the slope at that specific point. So that actually is the slope of the tangent at that point, and it is also called to be the slope of the graph. So here thus we find out the slope of the tangent by differentiating this above equation first generally, and then specific coordinates are to be put up. Now when we differentiate this generally, we get minus half, which is a constant staying outside, the derivative of x becoming 1 and the derivative of minus 1 becoming 0. And now when multiplied, the derivative will come to minus 1 upon 2. And as you can see that there is no x coordinate and y coordinate, that means it is not dependent on any x or y. And thus we can say that the derivative is always going to come to be minus 1 upon 2. And since this is the slope of the graph or the slope of the tangent to any point in the graph, thus it will remain to be minus 1 upon 2, and since it's negative, it will actually give you a strictly decreasing function. Now this is also depicted by trying to draw a graph of this. So we have the x-axis and the y-axis, right? And then we can make a straight line such that its slope is always negative. So obviously it will be, say, something like this. This is one of the ways that we can plot the line. The other can be, as we know that we have now the relation between x and y, or in other words, here we can further write this to be, say, 2y, which is going to become equal to minus x plus 1. Or in other words, we can say that y can be written to be equal to minus x plus 1, which is divided by 2. And as such, now if you keep the different values of x, correspondingly you will get the different values of y. And then what you can do is you can make a structure, say something like this, right, where you keep the different values of x, the independent variable, and you get the corresponding values of y, right? So this is normally what you do when you have to find out the value of the variables when you talk about two straight lines intersecting by the graphical method, right? So here you keep different values of the independent variable, and correspondingly you get different values of the dependent variable, and after that you plot the points on the x-axis and y-axis, and then you get a line. So that too you can do very easily now that we have the equation of the line, and you'll find that the line will come something like this. And then you find that the angle which the straight line makes with the positive direction of the x-axis in the anti-clockwise direction above the x-axis, which is what is a requisite for finding out the slope, will come out to be an obtuse angle, right? And since it's obtuse, tan of an obtuse angle that is in the second quadrant, which is like 180 minus theta, right, will be negative, as tan is only positive in the first and the third quadrant, right? And thus this also shows that the slope of this straight line is going to be negative all through. As such, this represents a strictly decreasing function. So is all of this clear with you people? For sure? Well, I'm sure if you've been here till the end of this lecture, you've been able to understand everything. Now, one thing more, I'd like you people to quickly jot down all the notes, do the sum as I've done it. I'm sure when sums will come your way of this type, you'll be able to tackle with it. Obviously, if there are other sums which you're not able to understand, for that you just require to click on the form which is there in the description. Tell me what your problem is, and then I will help you out. So make sure, children, that you study well, right? And you see that many topics on mathematics are actually interrelated, and when you have in-depth knowledge of each of these, very easily you'll be able to apply all of these and get to the final answer. Moreover, if you really want to fast track your journey, make sure you also fill up the form and tell me that, sir, I want to get to 100%. So I'll make sure that I carve out a journey for you so that very quickly you start getting results, and by all of these successes, you will feel really elated. Okay? Do write your comments as to how you found this lecture and what next you'd like me to help you with. Moreover, I'm always standing there to help you out. I'm Saurabh Kumar Das, and this is the Mathematics Helpline, which always tries to help you out. Bye. Make your mathematics strong. Bye.